Good evening. Please type in the chat box. Can you hear me? Good evening all. Can you all hear me? And can you see the screen clearly? Please respond. Type in the chat box. Can you all see me and can you hear me? Can you all hear me and can you see the screen clearly? Okay. Brightness. Just a second, guys. Chart is coming. Yeah, it's okay. It's not visible today to read your comments. Yeah, anyhow. So as you know, we are going to start the topic of differential equations today, and we have finished basically two modules, the single variable calculus and the multivariable calculus. You know this, correct? So by yesterday we have finished the module of multivariable calculus, and today we are going to start this concept of differential equations. Now, why differential equations is really important in engineering? Can any one of you tell me why this concept of differential equations is really important? I couldn't see your chart actually, mobile phone, because I couldn't see the chart today. Just a second. Brightness. Okay. Yeah, good evening. Yeah, I'm fine, Kalimula. So, can any one of you tell me why this differential equations is really good? Yeah, good. It's coming now. DE captures the real life physics. Okay, how it captures the real life physics? BVR. Any example of something? DE captures the real life physics. Yeah, of course, we need differential equations for modeling physics. Correct? Basically, we have two set of problems in engineering. One thing, we'll convert the physical phenomena into some mathematical modeling. Correct? By observing some physical phenomenon, we'll try to convert this into some mathematical models. Mathematical modeling. Now, how to do this? Let us try to give an example. Let us suppose, yeah, correct, many practical applications such as circuit theory, okay, heat equation, fluid equations, then geometrical interpretation of solutions. Yeah, all of you are correct at some moment. So now, basically, if you combine all your answers, basically, if some physics is happening, you will try to convert that physical phenomena into some mathematical modeling. For example, let us observe some physics here. Let us suppose there is a road, okay, and let us suppose there is one cycle going on. Let me draw some cycle so you can feel some happy here. Okay, so there is one cycle that's going on here. Now let us suppose this cycle is going with a speed v, and let us suppose it is traveling a distance s in a given time t. Let us suppose this is the physics that's happening. Means there is one cycle which is going on a road. Now, if you want to convert this into mathematical models, and if you want to study something about the geometrical movement of this vehicle here, then you have something called velocity. Correct? Velocity is something that defines the motion of this object. I am just giving a common example which any of you could understand. These examples you might have done in your 8th or 9th standard, hardly. Correct? So if this cycle is moving, this velocity is some parameter that talks about this movement of this cycle. So we know velocity is nothing but rate of change of time. Correct? Velocity is nothing but rate of change of time, and this is some differential equation. Correct? You have seen some derivative constant, and if this v is given in terms of some function f of s, then f of s is equal to ds by dt. Okay, let us suppose at 1 meter distance the velocity of this cycle is 5 meters per second. At 2 meters distance the velocity of this cycle is some 8 meters per second, something like this. If they give this velocity in terms of some function distance, then you got a differential equation. Correct? Means basically differential equations are used to convert physical phenomena into mathematical modeling. Then once we convert this physics into mathematical modeling, now we try to obtain solutions of these mathematical equations. Correct? Once the main art of any physical phenomena is you want to study the parameters that are involved. So for example, if a ball is falling, or if some current is flowing through your wire, or if some beam is deflecting, if you are seeing all these cases, then every physical phenomena can be converted into some mathematical modeling, and those mathematical equations are generally solved for obtaining solutions of this particular physical phenomena. So this differential equations is really important. So now if you talk about these applications of differential equations in your engineering, let us start with mechanical people. Mechanical guys, we generally use this. See, this is an example itself of a differential equation. If you go for civil, we deal with deflection of beams, where the deflection curve could look something like this. EI d square y by dx square is equal to minus mx. This is a differential equation. Other guys, don't bother. Just for your information, I just want to tell you that this is a differential equation. Correct? If you are from ECE or EEE, you know instantaneous current at any moment is nothing but dq by dt. Correct? A very small charge at the instant flowing divided by the time. So I is equal to dq by dt. Sometimes you will be getting this I in terms of charge as well. So I is equal to dq by dt. These are fundamental equations where you'll be taking the help of differential equations. Yes, I am from mechanical. I understand. Yeah, I hope you got it by this time. So similarly, if you are from CSE and IT, you will be performing many probability integrations and all where you could use this hardly. So now coming to the gate point of view, how these differential equations could help us. First of all, we talk about forming, first of all, there are two kinds of problems. You will convert physical phenomena to mathematical modeling. Means what you'll do, by looking at this physical phenomena, you'll try to form some mathematical equations, and since this chapter is dedicated towards differential equations, this comes to differential equations. Okay, so basically by looking at some physical phenomena, you'll see how this physical phenomena has got converted to differential equations. Now, which means by looking at this physics, you should be able to form some differential equations. So first important thing is forming a differential equation. Correct? If you want to analyze some physical phenomena, you should form some mathematical equations for that, and we need to form an equations. And to be precise, in this chapter we'll see how to form a differential equation. Next, once if the differential equation are formed, then the most important step is you need to solve them. Correct? If you convert this physics into mathematical form, that's not enough. You need to obtain solutions for these equations. So solving a DE. So these are two very important steps that are involved in engineering applications as far as a DE is concerned. Correct? Now we'll see what is a differential equation, what are types in that, how to solve different types of differential equations and all. But do you understand that basically there are two set of problems? One involves the forming of differential equation and the other involves solving of differential equation. Did you all understand till this particular point? All of you, please respond. Did you all understand till this particular moment that forming a DE is one set of physical applications, and then obtaining the solution of the DE is some other part of that? Yes? Okay. So if you understand that, now let us see what are different types of differential equations and what is a differential equation. And of course, I'm not going to write each and every definition elaborately because I have already done it in comprehensive course. So if you are lagging in any of the basic concepts, I strongly recommend you visit comprehensive course for the same lecture. Okay, so now see here, what is a DE? Any equation involving differential coefficients. Involving differential coefficients. And what are differential coefficients? What are differential coefficients? You know, dy by dx, then second order derivatives, d square y by dx square, or something, maybe square of the first derivative, dy by dx whole square. Look, these two are not same, okay, because I have seen many people using them analogously, but they are different. This is second derivative of f with respect to x. This is square of first derivative. You know, your f double dash of x and f dash of x whole square, these two are not equal, correct? You know about this. Yes or no? Can you all understand that these two are not equal? Correct? So please never substitute, this in place of this or this in place of dy by dx whole square. Okay, please don't do that. So now, if you want to look for an example, any example, x square into dy by dx plus y square is equal to 0, something like this. Any example that you could write. For example, you can write one more equation, some constant into d square y by dx square is equal to some function of x. This is all you can write here. Okay, now in differential equations, there are two types of differential equations basically. One is ordinary differential equations and other is partial differential equations. Since we have dealt with single variable calculus and also multivariable calculus, at this moment we'll try to identify what is an ordinary differential equation and what is a partial differential equation. Okay, because for these two equations, the definitions of order and degree are same. I want to define you this order and degree for this differential equations, which holds equally good for both ordinary and partial differential equations. Okay, so what are ordinary differential equations? The equations are the differential equations involving only a single independent variable. Only a single independent variable. Correct? And if you see these two equations above, we have only one variable as independent variable, correct? In single variable integrations or single variable calculus, we have only one independent variable and one dependent variable. And if you see this particular case, we have y as the dependent variable because we are differentiating this y with respect to x. Same is the case here. But in case of partial differential equations, as we have seen in multivariable calculus, we will be having many or more than one independent variables, correct? So you have seen basically if there is a function involving two independent variables, then we can't differentiate this function completely with respect to a single variable. So what we do, we'll consider partial derivatives, correct? Then if you see, we have more than a single variable, single independent variable. So you can write the dE involving. See, I'm just quickly going through the things. I have given detail of each and every point that I'm writing here in my comprehensive course on the same channel. So please, you can find the link in the description video of this, description box of this video, so you can go after this class. So the dE involving more than a single independent variable, more than a single independent variable. Okay, so examples of ODE and PDE, if you want to write examples of ODE, you can always write these examples: x square into d square y by dx square plus y square is equal to 0, some equations. And for PDE, if you want to write, you can write dou square u by dou x square is equal to minus c square dou square u by dou t square and all. You can see here this u, which is independent, which is a dependent variable, is depending on x and t. Both are independent variables. So whenever it's obvious, whenever a particular variable or a particular dependent variable is depending on more than one independent variable, we go for partial derivatives, correct? So if the differential equation is involving partial differential coefficients, then we call it as a partial differential equation. And of course, if it's involving only a direct differential equations, direct differentials or ordinary differentials, then we call this as ordinary differential equations. Is that clear? Can you all understand that there are two kinds of differential equations? One is ordinary and the other is partial differential equation at this point. Can you all understand this? Yes? Okay. If I'm going a bit quick, yeah, please try to cope up because this is the revision course. Okay. So next, one very important definition, which is order of a dE. Please be careful. I'm not mentioning any O or P here, correct? I'm not telling you whether this is an ordinary differential equation or partial differential equation. This definition of order and degree of a differential equation holds good equally for both ordinary as well as partial differential equations. Okay. So the order of a differential equation is, look, the order of the highest derivative, involved in a differential equation. For example, if I have a differential equation like d square y by dx square plus dy by dx whole cube plus some function of y is equal to 0, for example. Let us suppose I have a differential equation like this. Of course, you can see there are differential coefficients here. Now, if you talk about the order, look, this is a first order derivative, correct? And this is a second order derivative. So if you compare both these derivatives, which is of highest order? It's involving a second order derivative, which is big, correct? Which is a higher order. So we call this order as 2. As a second order differential equation, even though you have a cube here, because our definition of order only talks about the highest derivative, order of this highest derivative. And as per the given definition, you can see second order derivative is the highest order derivative that's lying in this equation. So it doesn't matter what's the power of the single order derivative, but it always matters what's the order of the differentiation that we are doing here. So did you all get the idea of what is order? Let me give you one more example. If you have dou square u by dou x square is equal to some function c square into dou square u by dou t square. Can you tell me what's the order of this differential equation? Can you tell me what is the order of this differential equation? It's again 2, because you can see clearly here, even though u is a function of x, it's a function of x and t, both are involving same second order derivatives. Even though the equation is something like this, so for example, dou square u by dou x square is equal to c square into dou u by dou t, then we call this as order 2, because the highest order derivative that's involved here in this equation is of second order. Okay, it need not be mandatory that whenever in a partial differential equation the order of both these terms should be same. Okay, it need not be mandatory. Even if you have a single term of this higher order derivative, then definitely we call that particular order as the order of the differential equation. So did you all understand what is order of a differential equation? Of course, we have few gate problems that are in beside slides. We will solve them at points. Clear? Did you all understand what is the order of a differential equation? Okay, next. Let us solve what is, let us try to, what happened? Okay, let us try to understand what is degree of a differential equation. Degree of a differential equation. See, order is very easy to identify, but while identifying degree, you need to be a bit careful. Let me tell you why. See here. Let me, write this. Degree of a differential equation. The degree of a differential equation, the degree of a differential equation is the degree of highest order derivative is the degree of highest order derivative involved in the equation when the equation is, this line is really important, you need to make a note of this, when the equation is free from fractional powers. When the equation is free from fractional powers. Of course, I have covered all these topics, but still I just want to revise quickly. Okay, fractional powers. Or these fractional powers are also called as sometimes radical powers. You might have gone through the chapter radices in hopefully in class 7 or 6, something like that. This is another name for fractional powers. Okay. Now, if you forget this point which I have written in this color, look what happens. If I have a d square y by dx square plus dy by dx whole square plus y is equal to 0. Let us suppose I have a degree like this. I have a degree like this, differential equation like this. Now, if you talk about order, order of this differential equation is, since second order derivatives are involved, you will tell this as 2. Can you tell me what is the degree of this differential equation by looking at this definition of degree of differential equation? It is the degree of the highest order derivative whenever the equation is free from fraction powers. And if you see clearly, I'm happy all of you are answering correctly. There is no fractional powers involved. If you see the power is 1, here also the power is 1. So there are no fractional powers involved literally. So you call this as, degree of degree 1. Okay. Now, let me try to give you some other degree. Second order and first derivative. Now, let me try to give you some other. D square y by dx square plus dy by dx whole power 2 by 3. Okay, let me remove this term for simplicity. First of all, whole power 2 by 3 is equal to 1 plus dy by dx whole power 3 by 2. If I take this differential equation, for example, now can you tell me what is the degree of this differential equation by observing the definition of degree? Any one of you? Since we have covered all these things, we are just revising the things. So can you please tell me? It is 1, 4. Second order, no degree. Okay. 4. Okay, let me check. See here. First thing, you can't write this 2 by 3. Okay, because I have seen in few questions, they'll give these fractions as options. Okay, so you can't write this 2 by 3 thinking that, see, as you have written this 1, because this 1 is the degree of this highest order term. Similarly, some of you may think this 2 by 3 could be the answer because this 2 by 3 is the highest power of this, is the degree of this highest order derivative. But I told you, you can define degree only when this equation is free from fractional powers. And if you see, there are some fractional powers in that equation, correct? So if you want to define degree, first of all, you need to make this equation get rid of fractional powers. Now see carefully what you should do. If you think that since there is 2 by 3 here, if you want to eliminate this fraction, you see, let us suppose this is x. You have x power 2 by 3 is equal to y power 3 by 2, something like this. Correct? Now, since you want this higher, the degree of this higher order term, many of you might think that if you raise this to the whole power cube, then 3 gets cancelled. there comes a 2 here, and you may answer the answer as 2. And you may answer 2 actually. See, if you raise this to the whole cube, for example, if you raise this to the whole cube, then some of you may feel that this 3 and 3 gets cancelled. So we have x square, and this higher order derivative is free from radical powers. So you may write 2. But I told you it's not the highest order term that should be free. It's the equation that should be free from radical powers. So if you are raising this to the power 3, there comes a fractional power again here. Correct? Correct? So now for eliminating these fractional powers on both sides, let us raise the power to the LCM of both these denominators. So if you raise, then it could be something 6. Then the total differential equation will be free from radical powers. So the degree in this case will be 4. Okay. So that's why you should be very careful by eliminating these fractional powers at many instances. Okay, because there comes a questions where they give options as 2 by 3 or 2 and then 4, things like this. So you need to be a bit careful then. So can I go for the next question? Did you all understand how to find the degree and order of a differential equation? Fine. Now see carefully. Now in these differential equations we have first order and higher order. By this time you know what is order of a differential equation. So I am telling there are first order differential equations and higher order differential equations. Now this higher order involves both, all second, third order and higher orders and so on. Now in this first order differential equations, you know we have two types, basically the homogeneous and non-homogeneous differential equations and non-homogeneous differential equations. Next, in case of this higher order differential equations, there is one classification which is again homogeneous and non-homogeneous, of course, homogeneous and non-homogeneous, and also we have one more classification. This first order ds can also be classified as linear and non-linear. Linear and non-linear. Similarly, this higher order derivatives can also be classified as linear and non-linear differential equations. Okay, now this is the basic classification that we deal with, and we talk about each and every particular type of differential equation in very detail. Okay, so now let us try to see in first order differential equations what is homogeneous differential equation and what is non-homogeneous differential equation. Look, you know first order differential equation will be of this form, correct? Dy by dx is equal to some function of x comma y. Yes or no? Will you all agree with me if I say the first order differential equation will be something in this form? Because one thing, it should not contain higher order derivatives. Then if there is something power k here is equal to some function of x comma y, also better, then this dy by dx can also be written as f of x comma y whole power 1 by k, which will be again some function of x comma y. Correct? So can I write the standard form of any first order differential equation could look something like this? Yes or no? Please respond. Did we talk about this in our comprehensive course? So please tell me, all of you. Can I write any standard form of a first differential equation as dy by dx is equal to f of x comma y? Okay. Now if I can write that, now if you call this as 1, for example, 1 is a homogeneous first order DE. It's a homogeneous first order differential equation if f of x comma y is a homogeneous function of degree 0. Here homogeneous function of degree 0. And I told you what is the condition for having homogeneous, for this f of x comma y to be a homogeneous function of degree n, correct? You remember in partial differentiation I told you if f of kx comma ky is equal to k power n times of f of x comma y, then we say that this function f of x comma y is a homogeneous function of this degree n, correct? Did we talk about this? Please tell me. Did we talk about this? Yes or no? Do you all remember that this is the condition to say that this f of x comma y is a homogeneous function of degree n? Yes. So now see here, if there is some case such that this f of x comma y is a homogeneous function, for example, you have x square by y square, then this is a homogeneous function of degree 0. X square minus y square divided by x square plus y square, this is again a homogeneous function. So there could be some functions where you can have homogeneity of degree 0. So if you have such function f of x comma y here, it means any combination such that it could make a homogeneous function of degree 0, then we call this differential equation is a first order homogeneous differential equation. And of course, if this is not a homogeneous function of degree 0, then we call it's a non-homogeneous equation. Now, if some first order differential equation is given to you, can you all identify whether this is a homogeneous differential equation or a non-homogeneous? Clear to all of you? Please respond. If some first order differential equation is given to you, can you all tell me whether that could be a homogeneous differential equation or a non-homogeneous differential equation? Fine. Okay. So now, similarly, if you go for higher order derivatives, the general form could be something like this: dx power n plus next n minus 1 the derivative of y, and so on. Maybe some coefficients you can have k1, k2, and so on. Finally, kn times y is equal to f of x comma y, hopefully some function here. Okay. Now, please try to understand. If this is a higher order differential equation, can you all agree with me that this is the standard format of any higher order differential equation? Depending upon the value of n, you will have the order of the differential equation. Correct? Can you all agree with me that this could be the standard form of higher order differential equation? Suppose if my n value is equal to 2, then I'll be having a second order differential equation. If I have n is equal to 3, then I could have some third order differential equation. Things go like this. Correct? So now if this is the common case, then this is said to be homogeneous. This is said to be homogeneous if f of x comma y is equal to 0. Means on the right hand side you couldn't have any term. Clear? Okay. If this right hand side is 0 and if you have only the terms involving differential coefficients of this independent variable, then we call this function as, or this differential equation as, homogeneous. Otherwise it's non-homogeneous. Otherwise it's non-homogeneous. Now I'll give you an example. Please tell me whether it's a homogeneous or a non-homogeneous. Okay. Arbitrary constants can be, they are not arbitrary constants, they are actually the coefficients of this derivative terms. Okay. They can be in terms of functions of x, or they can be constants as well. Okay. So these are not arbitrary constants. This k1, k2 are not arbitrary constants. They can be some functions of x, or they can be some numerical values. Okay. That could be anything. But our main intention while deciding homogeneity of the differential equation lies only within this right hand sided term. Clear to all of you? Is that clear to all of you? Now I'll give you an example. Please try to say, I'll give you a higher order differential equation. Please try to say whether the differential equation is homogeneous or non-homogeneous. Okay. In the chat box, you please type your answer. Now, see carefully. D square y by dx square plus dy by dx plus y plus sin x is equal to 0. Can you call this equation as a homogeneous differential equation or no? Please tell me. Okay. Yes or no? No. Why? Because you can see if you write this equation, d square y by dx square plus dy by dx plus y is equal to, and this sin x is nothing but minus sin x. Yes or no? Which means you have a function on the right which is independent of these variables. Correct? Yes or no? And you generally deal with the cases where we have only f of x in BTech level. Okay, I mean in graduation level, undergraduation levels. Because if all the powers of y are 0, then you can get this function only in terms of x. So you can write if f of x is 0 also if you need it. Okay, so because of this particular reason, the function is not homogeneous. Is that okay to all of you? Can I go for the next part? Yes or no? Please respond. Can I go for the next part? Next part. Okay. So now one very important thing to identify is linear and non-linear differential equations. Linear and non-linear differential equations. Okay. How to identify whether a equation is linear or it's non-linear? Look, a DE is said to be linear. A DE is said to be linear if the DE doesn't involve higher powers of dependent variable and the terms containing product of dependent variable and its derivatives. Dependent variable and its derivatives. See what happens. Now, for example, if you have these terms, what does this mean? Higher powers of dependent variable means if I am dealing a differential equation which involves this dy by dx where x is a independent variable and y is a dependent variable, then this is the differential coefficient, correct? And also, if y is a dependent variable, then y square, y cube, y power 4 and so on. All these are higher powers of x. Higher powers of dependent variable, correct? If you want to call a differential equation as linear, then definitely these terms should not involve in that particular differential equation, which means this equation shouldn't have higher powers of this this dependent variable, and also it can't have the product of a dependent variable and its derivatives. And of course, if higher powers of y should not exist, then definitely this dy by dx whole square terms like this also cannot exist, correct? Because I told you d square y by dx square is of degree 1, but dy by dx whole square is of, it's like degree 2 if it's a first order differential equation, correct? Can you all understand this? Yes or no? Can you all understand this? Correct? Means if you want to call any differential equation as linear differential equation, it should not involve the terms which are involving higher powers of x, higher powers of the dependent variable, and it should not involve the product of the differential, this dependent variable and its derivatives. Means you shouldn't have terms like this, and also you can't have terms like dy by dx whole square, dy by dx whole cube, and so on. Yes. Okay. So now you can't have terms like this. Now I'll give you one equation. You please try to tell me whether that's a linear differential equation or a non-linear differential equation. Okay. So see here. If you have a differential equation like dy by dx plus sin y is equal to 0, can you tell me whether this equation is a linear differential equation or a non-linear differential equation? Any one of you? Just a second. So it's a non-linear differential equation. So because if you see this dy by dx plus sin y could appear something common for you, but you know this sin y expansion, if you write this dy by dx plus y minus y cube by 3 factorial plus y power 5 by 5 factorial, if you consider all these terms, which means this is a differential equation involving higher terms of the dependent variable, correct? So now you can see this is a non-linear differential equation. Okay, so sometimes in exam they directly don't give you the higher powers of dependent variable, but they'll try to put some series or some some expansions like this, basically which involve some higher powers of this dependent variable. Clear? Okay, so can I go ahead? All of you, can I go ahead? Okay, good. So see here, we'll start solving few questions. And of course, before going for the questions, let us have some more details on formation of differential equations, because you know, if you want to solve some differential equations, first of all, you should be able to form the differential equations. Correct? So let us try to see how to form a differential equations. Look, if you have, let us suppose we are having, since we are dealing only ordinary differential equations at this moment, let us suppose y is equal to some function a into e power x plus b into e power 2x, something like this. Means basically they'll give you some function in terms of f of x involving some number of arbitrary constants. Correct? Number of arbitrary constants means they'll give you y is equal to some function of x. This the function could be something like this, and this is a particular case whenever you have two independent variables. Now you can have many independent many arbitrary constants depending upon this f of x that they give you. Now how to form a differential equation? Look, when you are trying to form a differential equation, the order of the differential equation should be equal to the number of solutions should be equal to the number of solutions. The number of arbitrary constants. I'm extremely sorry. The number of arbitrary. Something happened. Okay, see here. The number of arbitrary constants in the solution. You will see why whenever you are trying to solve some differential equations. Okay, arbitrary constants in the solution. Fine. So this is what we have, because generally when you start solving a first order differential equation, you will see in the solution there comes a single arbitrary constant. Similarly, when you try to solve a second order differential equation, you will see there are two arbitrary constants that appear in the solution. So in general, the number of arbitrary constants that appear in solution of any differential equation will be equal to the order of that particular differential equation. Clear? So now if you see, similarly whenever you are trying to form a differential equation from a given solution, then the order or the maximum order derivative you can use should be equal to number of arbitrary constants. Now let me try to give you one shortcut directly here. In my basic comprehensive course, I have made people to solve for that, but now we can write the equation directly. If y is equal to e power k1x plus e power k2x, if you have this, then the dE corresponding to the solution is equal to y double dash minus k1 plus k2 into y dash plus k1 into k2 into y is equal to 0. This is what the differential equation looks like for this particular solution. Means in general, if you have y is equal to a into e power x plus b into e power minus x, then you can form a differential equation normally by differentiating this two times. Correct? I told you y is equal to derivative of this is a into e power x, and derivative of this will be same as minus b into e power minus x. And also you can use the second derivative because there are two arbitrary constants involved here, so you can go for maximum second order differentiation. And if you differentiate this, y double dash is equal to again a into e power x, this minus, and if you differentiate this e power x once again, you will be getting minus into minus, so plus b into e power minus x. And if you see, this is y double dash is equal to y. Correct? And can I write y double dash minus y is equal to 0 as the differential equation? So basically what you will do, you will try to, depending upon the number of arbitrary constants, you will try to differentiate that given solution that many number of times. For example, in here in the solution you have two arbitrary constants, so you will differentiate this function twice, and then using all these three terms, you will try to eliminate this arbitrary constants a and b out of these two equations, out of these three equations, and you will try to get something in terms of y, y dash and y double dash. Clear? Did you all understand this? Did you all understand this? Yes or no? All of you, please respond. Did you all understand this? Whenever you have two arbitrary constants or number of arbitrary constants in a given solution, then you will differentiate the function those many number of times, and using all these equations that you obtained here, you will try to eliminate these arbitrary constants here. Okay, so please try to write this. So if you apply this logic or this short point that I gave here for this equation, look, I told you y is equal to some constants, maybe a into e power k1x and b into e power k2x. Okay, where a and b are some arbitrary constants, they doesn't matter. So now if this is the solution of any given differential equation, then the dE corresponding to this solution can be obtained in this way. Correct? This is what I told you. Now if you try to solve this equation using this particular result, y is equal to a into e power x plus b into e power minus x. Can you tell me what are the values of k1 and k2 here? Can you tell me what are the values of k1 and k2 here in this case? If you compare this equation with the standard form of a into e power k1x plus b into e power e power k2x, the value of k1 and k2 are 1 comma minus 1. You know this, correct? So if you take k1 is equal to 1 and k2 is equal to minus 1, then if you apply this equation, y double dash minus k1 value is 1 plus k2 value is minus 1 into y dash plus k1 is again 1 into k2 is again minus 1 into y is equal to 0. This is the differential equation. And you know this 1 minus 1 will give you 0. So 0 times of y dash is 0. So this implies y double dash, and 1 into minus 1 is nothing but minus y is equal to 0. This is the differential equation which you obtained in single step by using this notation, and also that's the same thing which you obtained here. Clear? Now if something is given in this way, y is equal to a into e power k1x plus b into e power k2x, can you identify what is the differential equation that's governing here? Yes or no? Please tell me, all of you. Did you all understand this? Now, in general, if you have any function like this, means if they give you any function like some constant into f of x plus some arbitrary constant into g of x, again, if this is the solution of any dE, then the dE corresponding to the solution, then the dE corresponding to the solution is given by, I hope you know how to calculate a 3/3 determinant. Correct? If you know how to calculate the 3/3 determinants, then y f of x g of x, y dash f dash of x g dash of x, and y double dash f double dash of x g double dash of x. If you equate this determinant to 0, then this is the equation which gives the exact dE for the corresponding solution. Okay, so if you compare with this previous question also, you can get the same equation if you evaluate this particular determinant. Clear? So if this is any given function here, then this is the differential equation that corresponds to this particular solution. Is that understandable to all of you? Is that understandable to all of you? Okay, so so I would like to give you one question, so please try to answer this. Okay, I'll give you one question, so please try to answer this question. No, actually, okay, if you take that y is equal to f of x, let me change the terminology here. Let you take g of x and h of x. If you are misunderstanding that, I can, generally I take y is equal to f of x, but that's not the case here. So b into h of x. So now you can correspondingly change these functions if you change that terminology. I hope you understood this. Okay, this is nothing but g of x then h of x. If you change this combination, then definitely this could be g dash of x, h dash of x, and g double dash of x, h double dash of x. Okay, now I hope you won't get confused for y is equal to f of x and all. Okay, so next, is that clear to all of you? I hope I can move ahead at this point. Yes? Okay, so now I'll try to give you one solution, try to form a differential equation for that. Y is equal to a sine omega t plus b, where a and b are arbitrary constants. arbitrary constants. So please try to solve this question. It's a solution which is involving two arbitrary constants. If you see here, there are two arbitrary constants that are being given here. So please try to solve this. This is a solution of a particular differential equation. So can you tell me the dE corresponding to this particular solution? Any one of you? I'll give you some time. So please try to solve this. Yeah, I think there is 4 seconds gap between the live and my streaming here. Okay. I'll give you at max 2 minutes. Meanwhile, you can try to answer. This is the solution of a differential equation. So you need to identify what's the differential equation. Y double dash minus omega square y. What is that equal to? Y double dash. That's not an equation, Sai Kumar. It's just a expression. Okay. So what does that expression equal to? And one thing I would always like to say, if you're liking the content that's being shared on this channel, you can always subscribe to the videos, and also you can share them among your circles, and also you can subscribe to the channel if you're coming here for the first time, so that you could be notified from next time whenever we are launching something. Okay. Minus a omega square into sine omega t plus b is equal to y dash. So can I say something here? Y minus y double dash is equal to 0. Is it? Fine. Okay, since some of you are trying, let's go for the correct answer. Shankar, could you convert your answer to something short? Because I told you the differential equation should not involve arbitrary constants, correct? By taking the help of y, since there are two arbitrary constants here, by taking the help of y, y dash and y double dash, you should be able to eliminate the arbitrary constants, and you should try to form the equation in terms of y and x. Of course, it can involve y dash, y double dash and all. So please try to tell me how to solve this equation, and also please tell me what's the answer for this. So it's 2 minutes. I'm stopping this timer. Look. See, you got y is equal to a sine omega t plus b. Correct? Now what could be y dash? Y dash is nothing but a into differentiation of this sine of omega t plus b is nothing but cos of omega t plus b into omega. So this implies y dash is equal to a times of omega into cos omega t plus b. Now, if you differentiate it for the second time, then a omega into the derivative of this cos of omega t plus b is minus sine of omega t plus b into, again we have one omega. So if you simplify the things, we have y double dash is equal to, if you multiply this minus omega outside this sign, we have minus omega square into a into sine omega t plus b. This is what you have for y double dash of x. Correct? Now, can you feel something here that this a into sine omega t plus b I can replace again with y? Yes or no? Correct? So if I replace that, this is y double dash plus omega square y is equal to 0. This is something called simple harmonic motion. In class 11, you will be dealing this. Correct? Have you seen this equation in your class 11 in case of simple pendulum? Yes or no? Can you all answer? Did you talk about this particular thing in your class 11? Yes, correct. And this is nothing but the differential equation of a simple harmonic motion. Simple harmonic motion. If you look at this equation, then itself you can understand this is y is equal to a sine omega t plus phi form. Y is equal to a sine omega t plus phi is a standard equation of a simple harmonic motion. Correct? This a is the amplitude, omega is the frequency of oscillation, phi is the phase angle. All these things. Correct? Any idea Back to physics. All of you, is that clear to all of you? Please respond. Please type in the chat box. Okay, fine. So we have seen how to form a differential equations generally when some solutions are given, and also some basically the order and definitions of order and degree of a differential equations. So now we'll try to start solving some questions. This is of course a very old question. Okay, let us solve this question tomorrow because I didn't complete the first order differential equations. So please try to solve this. Because I didn't teach you how to solve first order differential equations, we'll skip that first question for some other time. So please try to solve this. The differential equation y double dash plus y cube into sin x whole power 5 into y dash plus y is equal to cos x cube. Can you tell me which kind of differential equation is this? What's the correct option for this? It's option B. Is it? Mauli, Jitendra, Suhas, Sridevi, you're also telling it's B. Okay, Ovila. So see here, good. Because it's option B, non-linear. Because I told you, if you want to have linear equation, then definitely that higher order terms and something like this or something like this, they should not exist. Correct? All these terms should not exist. Now, if you see this equation, we have something called y cube whole power 5. Correct? And y cube whole power 5 is nothing but y power 15, and we have a higher power of dependent variable sitting in the equation. So we say that this particular equation is non-linear. Clear? Yeah, I'm happy that all of you have answered it correctly, and the answer is non-linear. And of course, it's a simple question, so that's fine. Now, okay, before going for the next questions, let me give you something about solving first order differential equation. Only one method I would like to give you in today's class, and we'll see how to solve other standard, first order differential equations. Okay, so now if you see, any first order differential equation could look something like this. Correct? Yes or no? Is this the standard form of any first order differential equation? Is this the standard form of first order differential equation? Yes or no? Please type in the chat box. Yes. Now, if this is the case, sometimes there can be a possibility that this function f of x comma y can be written as a function in terms of x into a function in terms of y. Okay. Suppose if your f of x comma y is x square y or xy square, maybe x square by y square. If there is some situations like this, then definitely there is a possibility that you can write this function, which is a combination of two variables, in product of two variables. I mean product of two functions, each function being a single variable function. Correct? Can we write this f of x comma y as product of a single variable functions if there are few functions in this format? Correct? Yes. So now if you see, this can be formatted as 1 by psi of y dy is equal to phi of x dx. Correct? Can I write this? If you have things like this, dy by dx is equal to things like this, then can you bring this term which is on the right, means basically this psi of y, onto the denominator, and can you multiply this dx here? Yes? Hi Ram Lakshmi. So please stay focused and try to solve. So if this is the case, then can you feel that this left hand side of the equation is completely a function of y, and the right hand side of this equation is completely a function of x? Yes or no? Can you feel that the right hand side of this equation is completely a function of x and the left hand side is completely a function of y? Which means generally when you have some clubbing of variables, see on the left hand side there is both involvement of y as well as x. Similarly, this f of x comma y is also a function that's involving both x and y. So if you have things like this, then can we separate the variables to either sides of the equation? Yes or no? Can we separate them? Correct? In some special cases, we can separate them. So this form is called variable separable form, where you can split the function into two functions of single variables and then you can split. Now this, you know how to solve this equation? It's very simple. You know how to integrate the things. Correct? So integration of 1 by psi of y dy, and depending on the psi of y, you know how you can integrate, because we have learned how definite integrals and indefinite integrals in single variable calculus, and of course we know how to integrate any given function. We can integrate. Similarly, on the right hand side, we can integrate the things phi of x dx. So here you will be getting some function which is free from this differential coefficient dy, and here also you will be getting some function which is again free from this dx. So finally, when you solve these two integrals, you will be getting the solution for this equation, and this is called variable separable form, because we are separating the variables on either side of the equations. Variable separable form, correct? Yes or no? This form is called variable separable form because since we can split the variables. Okay. So now let us go to the first question that obtained first here. Yeah. GATE 1994, of course, a very old question, but I just want to talk to you. Okay. There are many methods for solving differential equations, and this variable separable form may not be possible for all differential equations. For example, if I have things like dy by dx is equal to x plus y plus 4, then is it possible that I can split this differential equation, or maybe something out x minus y plus 2 also in the denominator? Then is this possible? Can I split this equation into a variable separable form? No, I can't split. Correct? Can I split this equation in variable separable form? Yes or no? I can't. So whenever you see a first order differential equation, it's not mandatory that the equation can be solved using variable separable form. So apart from this variable separable form, there are a few more techniques where we can solve some first order differential equations. So we'll deal about them in tomorrow's class, but in today's class we'll talk till the moment of variable separables. Okay, so please try to solve this question. Option B, is it the correct answer? Option B. Okay, let me check. So for the differential equation dy by dt plus 5y is equal to 0. Now, yeah, B is the correct answer. See here. Now you can split this equation into variable separable form, which is minus 5y. So if you bring this y onto the denominator of left hand side, 1 by y dy is equal to minus 5 dt. Now this is a constant, and this left hand side is completely a function of y. So you can integrate. So when you integrate, the integration of this 1 by y is nothing but ln y, and the integration of this minus 5 with respect to t is minus 5t plus constant. Now to identify this arbitrary constant, they have given one condition: y of 0 is equal to 1. What does this y of 0 is equal to 1? Generally, if you are writing f of a is equal to something b, which means at x is equal to a, means at the independent variable value having a, this value of dependent variable is b. This is the meaning of this, correct? Whenever you are substituting some value in place of independent variable, this is the value of the dependent variable which you are getting. This is the meaning of this. Now if you apply same logic here, here t is the independent variable and this y is the dependent variable. So if t is equal to 0, then y of 0 is equal to 1, correct? If you apply this, when t is equal to 0, y is equal to 1. So let us put 1 in place of y and 0 in place of t simultaneously. So log 1 is 0 to base e, and this is also 0. So which means c is equal to 0, which means log y is equal to minus 5t. So y is equal to e power minus 5t is the solution for this, which is given in option B. Okay. And this is a very simple question which you can solve very easily, and hardly takes not more than some 25 seconds to solve this, or maybe some 40 seconds at maximum. Correct? So can I go ahead from this part? I hope all of you can answer this. Yes. Okay. So let me, this we have already solved. And yeah, third, GATE 1999, civil engineering. So please try to solve this. One thing that's expected is in differential equations, we are getting a bit easy questions to answer. Okay, there are no much logics that are coming in GATE in recent years. But of course, these are very old questions. Since I thought of discussing many questions, I considered, since past 1990s and all. But in recent years, the questions from differential equations are quite answerable in exam. Okay. So please try to solve this equation. The solution of the dy by dx is equal to 1 plus y square. You see, there is no involvement of x here. and many of you are getting C. Okay, let me try. So this implies this, if you try to separate it into variable separable form, this 1 plus y square is on the right hand side. So let us bring that to the denominator, is equal to dx. So now if you integrate this, this is nothing but the integration of 1 by 1 plus y square is nothing but tan inverse y, because you know the derivative of tan inverse of y is 1 by 1 plus y square. So integration of 1 by 1 plus y square is tan inverse of y, and this integration of dx is x plus constant, which is y is equal to tan of x plus constant. Okay, this is the solution that you have, and you can have this in option C. Yes. Okay. So I hope these questions are very easy, but these are previous gate questions actually. Okay. So let's go for the next topic. And always, if you want notes of any lecture that's going on here, you can always click on to the links that are coming in the chat box. You know, mechanical students can click for that link where it was written ME students click here, and ECE, TEEE and all other branches excluding mechanical can, you know, click the link for the link starting with ECE, TEEE and all. Okay, but if that link has to work, you should definitely install Telegram in your device. Okay, and also subscribe to that channel so that you'll be getting the notes of each and every class that we are conducting here. Okay, so please, yeah. Okay, so let us try to solve the next question. Please try to solve this question. It's a GATE 2005 production and industrial engineering question. So please try to solve this. So please try to solve this question. Yesterday's notes was not uploaded. Okay, I'll do it today. Maybe I think I missed it. Nayanda, is it option C, second order and second degree? Okay, I'll upload. Don't worry. Today I'll upload. We have the PDF anyhow. We saved it, so we'll upload. C is the correct answer. Yeah, of course, you know, first of all, one thing, the highest order derivative involved is second order. So these two options are wrong because they are telling the D is of third order. Next, out of these two, you know, the power here is 2 and the degree doesn't have any fractional powers at any instant. So straight away you can write the degree of this d square y by dx square as the degree of the differential equation. So C is the correct answer. Now I hope all of you are comfortable in identifying what's the order and what's the degree of a differential equation. Correct? Is that clear to all of you? Yes? Okay. So please try to solve this. The degree of the differential equation, GATE 2007 civil engineering, d square x by dt square plus 2x cube is equal to 0. Can you tell me what's the degree of this differential equation? It is 1. It's obvious. There is only one differential coefficient that's involved here, and there is no fractional powers here. So definitely the answer could be 1. Yes, correct. All of you are correct. The answer is 1. It's a very simple question, but of course it's a previous GATE question though, 2007 civil engineering question. Okay, so let me go for next question. Yeah, this is the question. So please try to solve again. GATE 2007 civil engineering solution. Question is something like dy by dx is equal to x square y. So please try to solve this. Option B, Nayanda. Let me check. Let's others to answer. Bye bye. B, D. Still any more answers? Only B and D. Okay. D is the correct answer. Is it? Let me check. So see here. The differential equation is dy by dx is equal to x square y. Now it's obvious it can be converted to variable separable form. If you convert this, 1 by y dy is equal to x square dx. Correct? So if you integrate them, because it's a variable separable form, integration of 1 by y is ln y and integration of x square is x cube by 3 plus constant. Now to get the value of this constant, they have given one condition. Y is equal to 1 at x is equal to 0. Means in this equation, if you put y is equal to 1 and x is equal to 0 simultaneously, can you get the value of C? Yes or no? Please tell me. In this equation, suppose if you can put Yeah, I solved Ovila. We have solved few XC questions as well in calculus. I'll solve them also. Okay, so no issues. Are you from mechanical? Are you from mechanical, Ovila? It's okay. Anyhow, we'll solve XC. So please see here. So if you put y is equal to 1 and x is equal to 0 simultaneously, you can get value of c, because ln 1 is equal to 0 cube by 3 plus c, and you know this implies c is equal to 0. So if c is equal to 0, this equation is nothing but ln y is equal to x cube by 3, and this implies y is equal to e power x cube by 3. This is the solution. Okay, many of you might be answering B, feeling that since there is plus c here, you'll be getting this value of, you know, c as 4, but actually we'll be getting the value of c as 0 because of this particular. I'm sorry for this exclusively. There's small issue with this thing. Yeah, see here. So I think I'm going to break this today. Okay. So anyhow, y is equal to e power x cube by 3 is the correct answer. Okay. The value of the coefficient is, the value of the arbitrary constant is 0. Okay. Next. This is the question. So please try to answer this. The order of the differential equation. What is the order for this? GATE 2009 ECE. So what's the order of this differential equation? Look, whoever is attending here for the first time, please don't feel that we are discussing only easy questions. Okay, we have solved quite good number of tough questions as well, but this particular topic is only regarding order, degree, and forming differential equations today. So we are getting many easy questions. Okay, so whoever is attending here for the first time, don't feel like we are solving only easy questions at this moment. In calculus, we have solved many questions where, you know, hardly 1 or 2 students could answer in the chat box. Okay, so please don't misunderstand it. Now, you know, since this is the highest order derivative that's involved here, and it is 2. Since he's asking only about the order, we don't bother about what is the differential equation, but we'll just focus only on the term that's containing the higher derivative. Okay, so since second order derivative is the highest order derivative that's involved here, we call about this order of this differential equation as 2, and that's what many of you have answered correctly. So please try to solve this question. Solution of the differential equation, something like this. It represents a family of which of these following curves? Ellipses, parabolas, circles, and hyperbolas. So please try to solve this. The equation 3y into dy by dx plus 2x is equal to 0. If you solve this differential equation, the answer could be something which could represent a family of one of these curves. So please try to answer this question. Meanwhile, I'll be having some water, so please solve this. So now I think you're audible. Fine, it's okay. Okay, so I hope I'm audible to you now. Clear? Is my voice still not coming to you? Yes, I hope I'm audible now. So please see here. So if you can make a little manipulation here by shifting this plus 2x onto the right hand side, this is how you can split this differential equation into variable separable. So now if you integrate this, this implies 3 is a constant which can be taken out, and integration of y dy is y square by 2 is equal to minus 2. If you take out, integration of x is nothing but x square by 2 plus constant. 2 gets cancelled, of course, and this implies y square by 2 by 3. If this minus x square, if you shift on to the right hand side, to the left hand side, you will be having plus x square is equal to c. This is the equation which we have. Correct? Now see carefully. The equation that is with us is y square by 2 by 3 plus x square is equal to c. Can I divide with c the total equation? If I divide with c, I will be getting y square by 2c by 3 plus x square by c is equal to 1. Yes or no? Can I write this as x square divided by, this can be written as square root of 2c by 3 whole square, or I think this could be y square. Sorry for this. This is actually y square plus x square by root c whole square is equal to 1. Yes or no? Now, can you all tell me what does this curve represents? If you compare it with the standard form, x square by a square plus y square by b square is equal to 1, where a is not equal to b. Can you all tell me what does this equation represent whenever a is not equal to b? It's a ellipse. Correct? So that's why this is an ellipse. And for a given, if you keep on changing the values of c, we'll be getting many number of ellipses. Correct? Of course, with center of the ellipse at origin. Yes or no? So this is a representation of ellipse, and since this c is an arbitrary constant here involved, so for different values of c, you can get different ellipses. But of course, they are all concentric with center at origin, but the length of major and minor axis keep on changing. So this equation basically represents a family of ellipses. A family of ellipses. Okay. So I hope now all of you could understand why this will give you a family of ellipse. Yes or no? Can you all understand now why the answer should be ellipse? Look, many of you with your intuition, you can tell, since there is no xy term here and there is x square, y square terms, many of you may feel it could be a circle. But if you see, these denominators are not same. Correct? Ellipse is circle is a special case of ellipse when both length of semi-major axis and minor axis are same. Length of semi-major axis and length of semi-minor axis is same. But that's not the case here. You can see this is something different and this is something different. So that's why this is not a circle. Clear? To the people who have answered it as a circle, I'm giving the explanation why it's not a circle. Okay, because this a is not equal to b when you compare it with standard ellipse equation. Okay. Fine. Can I go for the next question? Okay. I just want to tell you something. Whenever you want, if you're trying to do something, don't bother about hurdles. Okay. Or don't bother about people who try to stop you. Let them give their try. You give your try. Okay. And you'll win definitely. So please try to solve this question. The Blasius equation, okay, this is some kind of equation which you see in fluid mechanics actually, but forget about it. What is this differential equation? That's it. That's the question for you. The Blasius equation, which is given by this particular equation, d cube f by dou eta cube plus f into d square f by 2 into dou eta square is equal to 0. What is this differential equation? Is it linear or is it of which particular order? You please tell me. It's of course, one thing, it's not a linear differential equation, correct? Because there is product of f and d square f. Yes or no? So first of all, one thing, it's not linear. So first thing, whenever there is linear in the options, you can delete that options. I think only in one option they have given. Next, second order nonlinear differential equation. Yeah, of course, this is a third order actually. So third order nonlinear, it's an ordinary differential equation. So option is B is correct. Okay. It's a third order, and also it's non-linear. Fine. It's option B actually. It, of course, since you can see this mechanical here, okay, because fluid mechanics is generally dealt by mechanical and civil students. So this question, it's quite common that it can come in one of their papers. But even though others can answer this, because for your knowledge, this is just one differential equation. Forget about what is f and what is eta. Just eta is a independent variable and f is a dependent variable. That's it. Okay. So if you compare that, this is the answer for that. Next. 2015. Again, we have some question from mechanical, I guess. So please try to solve this. I didn't intentionally put this mechanical questions here. You have seen ECE questions and also coming Yeah, that's the exact solution of actually Wonka-Man equation, momentum equation. So anyhow, it's been long back since I dealt fluid mechanics, but it's okay. So please try to solve this question. Consider the following differential equations. dy by dt is equal to minus 5. It's a very simple question, correct? So please try to solve this and tell me the answer. I won't solve this. You please try to solve this question, all of you, and try to tell me the answer. And one way, I mean, one thing that you could give us in return, if you're liking the content on this channel that's being shared, you can always please like the videos, then share them among your circles, and maybe writing some good feedback on the comments of this video. Not in the chat box, in the comment box. I hope you know what is comment box by this time. And you can always subscribe to the channel if you are here for the first time, because whenever we are conducting any lecture or any launch of any series, you will be notified and you can attend it from the first lecture itself. Okay. And also for getting notes, you can always subscribe to the Telegram groups that's coming, links for which are coming in your chat box frequently. C is the correct answer. Is it? Consider the following differential equation. Yeah, C is the correct answer because many of you are telling the same thing. Okay, C. Okay, then I hope C could be the correct answer. Let me solve anyhow. So dy is equal to 1 by y dy is equal to minus 5 dt. So if you integrate this, ln y is equal to minus 5t plus constant. So given an initial condition, y is equal to 2 at t is equal to 0. So ln 2 is equal to minus 5t plus 0. 5 into 0 plus c. So this is anyhow 0. So c is equal to ln 2. If c is equal to ln 2, then this complete equation could look something like ln y is equal to minus 5t plus ln 2. So if you bring this ln 2 to the left hand side, you have ln y minus ln 2 is equal to minus 5t, and this implies ln y by 2, because in yesterday's class I gave you basic formulas of some logarithms. So log a minus log b could be something like this, minus 5t. So y is equal to 2 into e power minus 5t. I hope this option could be given somewhere. 2 into e power minus 5t. Okay, since they are asking that t is equal to 3, if you put t is equal to 3 there, you will be getting 2 into e power minus 15, which is given in option C. Yes. Okay, and all of you are correct. Since this is a very easy question, you can solve this. Okay. C is the correct answer. Next. Right now I don't have any plans, Parvat, but let's hope soon. Okay. And anyhow, all mechanical guys can go to the basic thermodynamics course that I have taken in this channel. You can find the the course in playlists of this YouTube channel of Engineers Hub. Okay. So anyhow, that's a different story. So now let's get back to this question. It's a 2015 Tipley electrical question. In differential equations, majority you need not have the knowledge of graphs and calculus, and of course this is calculus actually, but graphs and all, as we have done in basic single variable and multi-variable calculus. Okay, this is something, if I teach you one thing, you can solve 10 problems based on that. But you have seen basic calculus is not something like that, and of course that's why we have done in very detail for almost some 14 days. So please try to solve this question. It's a 2015 Tipley. And whoever is attending this course, please don't worry, because whenever you're getting some calculations, I will solve them in front of you. Okay, in a virtual calculator. Okay, so you'll also be knowing how to use the virtual calculator at times. 8.2 Kamaludin, let me check. A differential equation di by dt is equal to 0.2i is applicable over that interval minus 10 less than t less than 10. Okay, then if I of 4 is equal to 10, then I of minus 5. So see here, since for any t in between minus 10 to 10 it's valid, so whatever the solution you get for solving this differential equation with this condition, you can substitute minus 5, because this t is equal to minus 5 is lying within this interval. So definitely you can, what are the solution you are getting for this differential equation with this particular boundary condition, using that solution you can calculate the value at t is equal to minus 5. Let us try to do that. 1 by 0.2. Okay, let us not move the constant. 1 by I is equal to 0.2 dt. Okay, so if you integrate this, we have ln I is equal to 0.2 t plus constant. This is what you have. Okay, this is the equation. Now I of 4 is equal to 10. So wherever if you put, you know, t is equal to 4 and I is equal to 10 simultaneously in this equation, you will get what is the value of C. Let me calculate what is the value of C. So ln I value should be 10. So ln 10 is equal to 0.2 into t is 4 plus constant. So what about C? C is nothing but ln 10 minus 0.8. How to calculate this value? Look, this is ln 10 minus 0.8. Let me show you how to calculate this value. Okay, now I'll be using virtual calculator to calculate the value of log 10 to the base e minus this value. See here. So this is the virtual calculator that's available with us, and that this is the same calculator that you're going to use in your final gate examination. Okay, so now you want to find log 10 to the base e minus 0.4. So I told you many times the main difference between your Casio that you use and this virtual calculator is, in Casio, if you want to calculate e power 5, first you will click e power x, then you will click 5 and you will put equal to, correct? But here in virtual calculator, if you want to calculate e power 5, first you will click 5 and then you will click this e power x function. Then you can see POWE of 5 means e to the power of 5 is something like this. Okay, this is the main difference between Casio and virtual calculator. In Casio, you will first type the function and then you will enter the value at which you need the functional value. But in virtual calculator, first you will type the value, then you will click the function that gives you the functional value. Okay, this is the basic difference. Now, since we are interested in log 10 to the base e minus 0.8, let us calculate that. 10. Now, you want log to the base e, which you can see here, ln, correct? This ln stands for natural logarithm and it's log 10 to the base e, and this log stands for log 10 to the base 10. Okay, but in questions we have log 10 to the base e at this particular question, so we'll click ln. So ln 10 means log of 10 to the base e is something this minus 0.8. This is the value 1.5025. 1.5025. This is the value of the arbitrary constant at this particular condition. Now I of minus 5. What could be I of minus 5? Ln I is equal to 0.2 into minus 5 plus constant. This is what you have. So I is equal to, look, 0.52 into minus 5 is nothing but minus 1. Minus 1 plus c is nothing but this value minus 1. So this is e power 0.5025. This is what the value of I at t is equal to minus 5. Correct? Did you all understand till this moment? Please respond. Did you all understand how this I value at t is equal to minus 5 is something like this? E power 0.5025? Yes or no? Please respond. Did you all understand how did the value of I is equal to e power 0.5025? All of you, please type in the chat box. Yes? Ovila, please make the calculation a bit correctly, because this value is positive and you are subtracting something which is less than 1. So e power 5025 could be the answer actually. Okay, so if that's the case, then let us calculate the value of e power 0.5025. Okay, minus 1, this is what you have, to this e 1.6529 is what you have. So this is 1.653 if you round off in general. Okay, so 1.653 is the correct answer. Okay, so in using virtual see, in exam you know how to do all these things, but if you don't know to use virtual calculator and get this value, that's it, your knowledge is not helpful for you in that time. Okay, so please practice virtual calculator as many times. Even for your core subjects, you please try to solve. You know, you can install this app. There's a in Play Store, it's available. You can download something called Gate Calculator and you can start solving, using this calculator for your calculations. Okay, so if you start using this calculator for your calculations, you'll be getting handy with all the functions by the time you appear for Gate. Okay, and values of this kind couldn't trouble you in exam. Okay, because in Gate exam, if you don't know how to calculate this value, then that's it. There is no use of knowing complete differential equations. Clear? So can you go for the next question? Can I go for the next question? Yes or no? Please respond. Okay. Ovila, I think by this time you identify what is this mistake. Okay. That's why you should be a bit careful with calculations. Okay, you know everything till this last step, but making one minus sign difference here will change your answer. Okay, this is one question, GATE 2018. So the degree of the differential equation. Can you tell me what's the degree of this? It's a simple question, right? But of course, since it's from 2018, I thought of putting it d square x by dt square plus 2x cube is equal to 0. And you know, there is no fractional powers here. D square x by dt square is equal to minus 2x cube. And of course, there is no fractional powers. The degree of this term, which is 1, is the differentiation or the degree of this differential equations. Okay, clear. Next, I'm going for the next question. Since this is an easy question and all of you have answered it correctly. Next, this is the question 2019 mechanical again. Luckily, sometimes they give you options like this. Okay, and sometimes they'll ask you for numerical answer type. If they give you options, then sometimes it's better that you need not use virtual calculator for things like this. But of course, if they give you fill in the blanks, then you need to calculate the values. Okay, if they give you options, it's actually risky, because if you see all these options are looking same, you know, almost same. 7 by 3, 3 by 7. Again here 7 by 3, 3 by 7 and all. So if you make small, you know, parallax error, that's it. Your answer goes on. Parallax error is something that you make by fault of eye. Okay. Normally in readings, you know, if there is a reading here, for example, if there is 50, 55 here, then for getting the exact reading, you should match your eye exactly to the level of this line. Correct? If you watch something from bottom, you will feel that this line could read something more. Similarly, if you watch from top, you feel this line is coming a bit down. Okay, so that's why any errors that are made by eye are called parallax errors. So in exam, please don't make them. Okay, please be careful. Option D, is it? What about others? Oh, I'm sorry. Yeah, sorry. This is the question. Yes. No answers. Option D. Taking so much of time? Okay. Solution. D is the correct answer? Okay. Since all of you are answering it D, I think D should be correct. Now let me check. dy by dx is equal to minus 7x square y. Okay. So let us try to bring this y to the bottom. 1 by y dy is equal to minus 7x square dx. And this, if you integrate, since this is in variable separable form, you can write ln y is equal to minus 7 by 3 x cube plus constant. Yes, correct. So this is what we have, and they have given the basic condition y of 0 is equal to 3 by 7. Means when you put x is equal to 0, value of y is 3 by 7. So this implies ln 3 by 7 is equal to, when you put x is equal to 0, this term is 0 and this is equal to constant, which means ln y is equal to minus 7 by 3 of x cube plus ln 3 by 7. This is what you have. So if you shift this logarithm to the other side, you have y ln of y by 3 by 7, which is 7y by 3 is equal to minus 7 by 3 x cube. Okay. So if you try to calculate the value of y from this, then it's simple. You can get it. Y is equal to 3 by 7 of e power minus 7 by 3 x cube. This is the solution for this. Now they are asking you at x is equal to 1. So if you put x is equal to 1, 3 by 7 into e power minus 7 by 3 is the answer. D. Correct. All of you have done it correct. Good. Okay. So fine. Is there any doubt to any of you at any point? Is there any doubt to any of you at any point? Okay. Now I'll ask you one simple question, try to answer. Look. Okay, see something here. Let us suppose I told you number of arbitrary constants lying in an equation is equal to the order of that particular differential equation. Correct? Of course, the number of arbitrary constants should be in the simplest form. What is the meaning of that? Look, let us suppose I have y is equal to c1, c2, c3, c4 into e power c5, c6, c7x. Let us suppose this is the solution of a differential equation I have. Okay. Now, if this is a solution that I have, now if I try to form a differential equation for this given solution, can you tell me what would be the order of this differential equation? Any one of you? We have 7 constants totally, 7 arbitrary constants. So if I try to form a differential equation, can you tell me how many are, what's the order of that differential equation? It is 2. Okay, it's not 7 because I'll tell you. No, it's 2 actually. I know few people will be telling 7, but see why. These 4 are arbitrary constants. So can I write the product of these 4 arbitrary constants as one single arbitrary constant? Yes or no? Product of 4 arbitrary constants is nothing but again is arbitrary constant. Similarly, product of these 3 arbitrary constants is also a arbitrary constant, and you will be getting y is equal to a into e power bx, and this is a differential a solution of a differential equation which is having only 2 arbitrary constants. Okay, so whenever you are considering number of arbitrary constants for forming a differential equation, you should check for the simple the arbitrary constants lying should be in the simplest form. Okay, means if there is a chance that you can merge 2 or 3 arbitrary constants into a single arbitrary constant, you should do it definitely. Fine. Did you all understand this? Now, of course, if you want to form a differential equation, it's very easy. Y dash is equal to ab into e power bx. So if you divide these two, this a and this e power bx gets cancelled. So b is equal to y dash divided by b. This is the constant. So if you put b is equal to y dash divided by b, you will get what is the value of a. Now by differentiating one more time, y dash is equal to a b square e power bx, and y dash is equal to ab e power bx. You can cancel this a, this e power bx, and this b. So y double dash by y dash is equal to b is what you have, and b is nothing but y dash by y. That's it. This is a differential equation. Okay, which is corresponding to this solution, and you have seen all arbitrary constants got eliminated in a single stroke here. Okay, so whenever you are if you are writing what's the order of a differential equation based on the number of arbitrary constants in the solution, you should be careful that these arbitrary constants which are lying there should be of simplest form. Clear? Did you all understand this? So whenever you feel you are given some questions like this, so don't answer for 7 and 8. Okay, this is the simplest form. Okay, clear? So any other things that you want to talk about here? I hope today questions are very easy, correct? Because I did since where can we get the password for the PDF which are there in Telegram channel of Engineers Hub? In Telegram channel of Engineers Hub, we don't have any PDF which is containing password. Okay, whatever the notes I am uploading, I don't know if there is password for some other notes, but whatever the notes I am uploading on behalf of maths and thermodynamics, there are no passwords. Okay, if someone has uploaded it, I don't know, let me check with them. So clear? So any more doubts that are with you, or any more questions? Tips to prepare for GATE. Is it, how many of you need it? You, me. Okay, I'll tell you something that's interesting today. Okay, since we got some 20 minutes of time, okay, I'll tell you. So generally integral gives sum of sum or area. Does it give change? Actually, that area will be calculating using sum. Okay, normally what integration do is 0 to x, y. I'll tell you some few tips about GATE. It's okay, but let us try to answer the doubt of Mahesh. So if you have things like this, if this is a and if this is b, what integration do is it gives the area. If suppose if this is y is equal to f of x, then definitely this area is nothing but integral a to b f of x dx, correct? What is the meaning of this is normally you'll see sum of infinite limits as as an integration, because I have shown you if you keep on attending this series, you will at one point will start learning something called numerical methods. I have taught one thing called trapezoidal rule. You remember? Look, in numerical methods that I taught in basic comprehensive course, I have given minimum to minimum some 7 to 8 to 9 methods. Even for a single method, I didn't give the formula directly. I gave the logical explanation behind it. Okay. Even for single method, did I give any direct formula in numerical methods for you, or did I give you some the formulas using some graphs, then some points and all? Did I give you any direct formula in numerical methods? Please respond. Whoever have already attended, did I give any direct formula for any of the method? No, I didn't give, because numerical methods is such a beautiful topic in mathematics, which is very helpful, because few questions which you can't solve using analytical methods, you can still solve using numerical methods. Okay, and all your devices, your Casios, your softwares, MATLAB, Simulink, whatever softwares you deal, they all work on numerical methods. Okay, so that is really important. So whenever, of course, we have some part in this course, we'll spend some time on numerical methods, then we'll go. And what this integration do is generally for small values of x, this will calculate this area first. For a small value of h, means this is a plus h. Okay, similarly it calculates this area, and then it calculates this area. So finally it sums up all these areas to give you this total area. Okay, so that's why integration generally means summing up of areas, because this dx which we are taking will be very small actually. So whenever you are integrating a function with respect to this small term dx, this means this practically adds each and every term and give you the final answer. So that's why integration is many times referred as addition, and differentiation, since we are talking at a point, it's basically its name is the differentiation. It breaks something into points. Okay, if you see this dx, it breaks this complete length into small lengths. Okay, so this is what integration, basically geometrical concern of integration. This is what I have mentioned in the first lecture also in basic calculus of integration, correct? No, it doesn't give any change. Practically it's very small. Of course we have some errors, but those are very minute when compared to the actual answers. Okay, so how many of you are writing tests? Okay, let's talk about gate, how to write gate and all. Or else, is there any other questions? Let me first answer technical things, or then I shall move. Or can I start? I'm waiting for your replies. I'll tell you how to answer the question paper. It's okay. But before that, is there any technical doubts? No, right? About gate. Okay. Fine. See here. I'll tell you something. Look, first of all, tell me how many of you are writing test series now in November. Please tell me how many of you are writing test series. Any one of you? Yet to start. Okay. Integral q by t change in s. I don't understand what is q by t and change in s. Okay. Okay. Few of you are writing and few of you are about to start. Okay, going to start. Look, I'm telling you one thing very honestly. Whatever you study from your beginning of undergraduation to November in final year, this is something different. And whatever you are studying from November in your final year or third year, maybe even third years can write gate to gate exam. This is really important. Okay, it doesn't matter whatever you study till this point. Now, whatever you revise in this time is really important. Okay, there will be many students. I have taught in nearly more than 2 states. So I have seen many students who will be answering the questions very fastly. By the moment I give the question, they'll answer it. Done. But by the end, when final gate result is out, they won't be able to qualify gate exam. You know why? Because there is something very important for writing this gate, which is called revision. If this is not there, that's it. You will definitely lose some 35 to 40 marks in your paper. I'll guarantee for that. Okay, because in gate examination there comes two kinds of questions. One thing, memory based means they'll ask you, there are many subjects in your engineering and there are many conceptual questions, and there will be some questions where you need to remember something and then write the answer. Correct? Memory based questions basically. For example, they'll give you something, for example, the boiling point of water. For example, it's 100 degrees centigrade, and of course it is saved in your memory, it's 100 degrees centigrade, so you'll be able to answer that. In exam, if you don't know this point, there is nothing you can do at some analysis or something, and you can write the answer for this. Correct? These kind of questions are memory based questions, and these memory based questions will come from the subjects which you read in all the 4 years. Correct? So there is quite possibility that some points in theory subjects you won't be remembering by the end of final year. Correct? Some theory subjects which you study in your second year and third year of BTech, there is 100% guarantee that you won't remember some good points of those subjects by the time you reach your final year. So one very important thing is revision. Now, how to revise the things? That's the important question. Look, I have seen many cases, they'll make a very detailed plan. They have 3 months of time. So what they do? First 10 days, one subject. This fellow won't study any other subject on these 10 days. Okay. Second 10 days, second subject. This is how they study. But actually this case doesn't work out, because by the time you reach your 70 to 80 days, 71 to 80 days, maybe 71 to 80 days, you will be starting your 7th subject. Correct? If you keep on doing this, by the time you reach this time, you won't be remembering these two again. You will forget these two if you do it in this way. Okay, so never go for this approach. Clear? Don't feel that after finishing off one complete subject, then I'll start the second, and then after the completion of second subject, I'll start the third. No, this type of revision never works out. I'm telling you honestly. How you prepare? Look, in the total time that you have in a day, make some partitions. 1 hour partitions if you are free. Okay, 1 hour, things like this. Okay, and yeah, if you ask people who have already attempted it, they'll tell you this kind of approach never works out. See, our friend is telling it. Yes, I made this mistake. So this approach, you'll forget these first chapters, these subjects. So it doesn't matter 3 subjects or 4 subjects. Try to make slot for every subject every day. Okay, at least some 45 minutes to 50 minutes. Okay, you make this slot. You revise something of subject 1. Again, you revise something of subject 2. Subject 3, something like this, depending upon your time facility. Subject 4. At maximum, you can leave 2 to 3 subjects that you can revise at the later. Okay, but please make this kind of strategy such that on every day, at least for some time, you will be reading every subject. Okay, next, when you go for this is day 1. When you go for day 2, before starting the subject revision here, look at these pages. Look, as per my suggestion, you please try to maintain one short notes. For example, let us suppose I have taught basic calculus for you. Then this complete basic calculus notes will come for 70-80 pages. Now, out of this 70-80 pages, you try to compress this 70-80 pages into some 3-4 pages or maximum 5-6 pages. Okay, this is called short notes. When you refer these short notes, everything which is in the main notes will get revised in your brain. Did you understand how to make a short notes? You'll write all the key points. If there are some important formula, you'll put it there. If there is some good concept, you will try to put it there. So make some short notes for everything. Okay, look, if you make some short notes for everything, then first day you got, let us suppose you got 2 pages for this subject 1 when you are revising. Okay, second day, whenever you are starting revision for this subject, please see these 2 pages first. Don't go for this revision directly. Please see these 2 pages first, and then you start writing this thing. Then you will be getting 4 pages of notes by the end of day 2. Correct? On day 3, again some more 2 pages. So you'll be getting 6 pages. Every day before starting your revision, go for the previous pages. Just scroll the pages once, see the notes, and then go for revision. You continue this for all the subjects daily. Okay. Then it's quite possible that you will be revising these things many times in a given time. I mean, many times in particular some period of time, and by the time you reach your final days, you will be having the knowledge of all these pages daily. It doesn't matter. You can revise half an hour, one subject daily. See, many of you are telling college hours, how to do this in college working days and all. What is the maximum time you spend in your college? Hardly, not more than 8 hours, correct? But there are 24 hours in a day, and you can still revise 7 to 6 to 7 subjects easily, very easily. So please try to follow this approach so that don't go for second subject after completion of first subject totally, but please try to go for this kind of approach. Then you will be remembering all these things without much loss of knowledge. Did you all understand how to revise this? If 2-3 subjects, if you are putting as backup, then you can revise those 2-3 subjects once you finish all the major subjects. In GATE examination, there are few topics where questions come very frequently. How to identify those topics? If you revise past 10 years GATE papers, or maybe past, at maximum past 15 years, even 15 is not so good, 10 years is hardly enough. If you revise past 10 years papers, you will identify few topics where questions are very often. Okay, so if you identify this, then first of all give importance for those subjects where majority of the marks are concentrated. Okay, if you can do this, if you can revise the subjects where majority of marks are concentrated, then you will be finishing this cycle within 2 months maximum, 1.5 months or 2 months. Okay, so by the time you reach 1.5 or 2 months starting from this day one, definitely 70% of your subject revision will get finished. Okay, and simultaneously it's better if you give test series after every 5 days or 6 days based on the topics that you covered on 5 days. Okay, for example, let us suppose daily 1 hour you are revising for one subject, and this subject has taken 15 days. Then after 7 days you can give one topic wise test. Then again after 7 days you can give one more topic wise test. Okay, so by this time this sequence gets completed, you will be able to solve all these basic test series and previous GATE questions and all. For going for any exam, previous GATE questions is really, previous questions for any exam is really important. Okay, because I'm telling you, hardly GATE is being conducted for more than 34 years as far as my knowledge is concerned. Okay, and all the questions what you solve have, all the questions that are going to come in future exams might have definitely came in previous years at any one of the year. Okay, so that's why I'm telling you, please refer the previous papers, and you should have very keen knowledge on previous papers, that if I tell you the question, you should be able to tell from which year it is. If you are at that level, your GATE exam will get completed within maximum 2 hours. All the 65 questions, maybe at least not more than, not less than some 55 questions. Clear? If you are at that level, if you are thorough with all the models of the questions that came in past 10 years or 15 years, then definitely by the time you see the question, you will definitely find the approach for that question in writing the solution. Did you understand? Did you understand how to revise the things? Clear? Did you understand how to revise? Now, if you revise this way, you will be having very good, backup of this revision. Now, how to write GATE paper? We have time. Yeah, we have some time. Let me tell you. Look, this is how your screen is visible to you. Yeah, till 30% is remaining. Now, how to use this 30%? After the completion of this, after the completion of all this syllabus, maintain at least some 15 to 20 days backup for covering this 30 days syllabus along the revision of all these subjects daily. Okay, means once these subjects are finished, you keep on writing. Of course, whenever you are at midway, you will be starting writing the test series. But once this test series is done, then along with this test series, refer this 30% syllabus also. Daily read one subject. Again, make this strategy for those 3 subjects or those 30% of the syllabus. And by the time you complete this, schedule in some time, then after the completion of this schedule, you go for again new schedule of that 30%. Then along with the revision of these subjects, you revise that 30% of the syllabus. Okay, next. How to write this exam? Look, many students, your exam screen looks something like this. Your photo here, maybe some hair also. Okay, then here there is virtual calculator. Here your name and all these things will come. And here comes the question palette. Means you have numbers. Question 1, 2, and all. If you click on any particular icon, then that question will get displayed. Okay, and here you will be having the question. Of course, some options, maybe some numerical answer type. You will be having some box to enter and all. Now, as soon as you open the exam, you start logging into the exam, and if your paper gets displayed, don't straight away answer the questions. If this is first question, then you do it, then go for second question. No, this approach don't work. Now, if you see, there are small buttons here: submit, question paper, instructions, and all these buttons. There is one button here which is called the question paper. Okay, many people who have already given gate don't know about this. There is one option here at this location which is called the question paper, and you know what happens if you click that question paper button, then all the 65 questions will get displayed in a single PDF. Okay, if you click this tab, then normally if the screen is like this, you can see only one question at a time. But if you click this question paper tab, your complete 65 questions will come as a PDF. Now, out of those 65 questions, try to mark some 30 to 35 questions which you are very thorough. If you can revise in this way, definitely by the time you sit in your exam, definitely some 30 to 35 questions will be very easy for you, just by looking at the question, if it's a theoretical question, or if the questions involve a single step calculation like the questions we have solved today, you will be able to answer minimum 30 to 35 questions. And since these questions are very well known to you, you should not commit two kinds of mistakes here. One thing, don't overread the question. You know, sometimes they'll ask you, for example, in this mathematics course, if you see, they'll ask you sometimes maximum at x is equal to. Sometimes they'll ask you maximum value is equal to. Okay. Some students, when they start reading the question, they feel this is the question for maximum and minimum, and they'll directly calculate this value. So in exam, if they ask you this question, but still if you enter this answer, then your answer is wrong. So never overread the question. Second thing, don't make any calculation mistakes. Please don't make, okay? Because the calculation mistakes are the only difference between top 100 rankers and top 500 rankers. Okay, so please don't make calculation mistakes. And these 30 to 35 questions, you should be answerable. You should answer them with 100% accuracy. Okay, so if you answer them, next you go for another 30 questions or 35 questions, depending upon this. Now, whenever you see this question paper, complete 65 questions on a single PDF, split this question paper into 3 categories. First category belongs to this 30 to 35. Okay, means directly answerable. Directly answerable means as soon as you see the question, you know the approach, you will solve directly. This is answerable but time taking. Okay, there will be some questions which you know the concepts, but the answers for them will take, means solving those questions will take some good time. So answerable but time taking. Not answerable directly. Not answerable directly. Try to split this question paper into 3 parts. But I'm pretty much sure if you revise the things very thoroughly, this part will have at least 40 questions out of the 65. I am sure for that. Okay. Many students, they don't qualify gate or they perform very less in gate because they don't have proper revision. They are very intellectuals, you know, their percentages, you know, their whatever you say, their knowledge on subject is very high, but they don't have revision, so they forgot many simple basics. Okay, so that's why they feel many questions are from this category. Okay, but if you revise thoroughly, many questions will be from this category. So first of all, try to mark the numbers of these questions which you feel. Whenever PDF is calling, you can read each and every question, so you'll get the idea. So write the question numbers of questions that fall into this set. For example, 1, second question I don't know, third question, 7th question, 9, 11, 13. Let us suppose there are some question numbers which belongs to this. Then after writing question numbers from this, solve all these 30-35 questions or maybe 40 questions. Next, once it's finished, then you know what are the questions already solved, because you can see the question palette here. There are different colors for answered questions, not answered questions and all. Then second, go for this, which you know the concepts, but which you felt there are some calculations and they could take some time. Go for this kind of questions. Okay, and again, if you are revising thoroughly, definitely some 15 to 20 questions could add here. 30 to 35 and 15 to 20 definitely could add here in this module. And very few questions, if you are 100% thorough with all the subjects, there will be very few questions which you can't answer directly. I'm telling you. You know, when gate paper, people say that this year paper is tough and all. No, actually that year paper came from the topics which are having, many questions in that paper came from the topics which are not frequently asked. That's it. But if you are revising this in this way, definitely you can answer questions from any particular subject. Okay, clear. So finally, you will be working out these things with the help of basics that you know in different subjects. Okay, so that's why you'll split this paper into this. Why to do this? If you don't do this, and if you start solving first question, second question, what happens? Let us suppose you know there is shuffling in the questions, obviously. So let us suppose you got first question here. Okay, you tried, you got the, if you get the answer, it's fine. Let us suppose you didn't get the answer. Means let us suppose for the first question there are 4 options. You solved this question and you got an answer which is not in the 4 options. Okay, which means you have made a calculation mistake. Next, second question. Let us suppose something also happened in your second question. Then in your third question, if it's a numerical answer type question, if you get calculation mistakes in these 2 questions, now tell me how dare you will be to put your answer in the numerical answer type box. Will you be willing to put it? If first 2 questions, if you have made calculation mistakes, and if third question is a numerical answer type question, please tell me, will you able to make your answer in the answer box? No, your mind game starts then. And you know, your mindset is really important in GATE exam, and nearly first 30 minutes to 1 hour time is what that decides your GATE rank that year. Okay, as soon as you see your question paper, if you keep on getting tensed or something like that, that's it, your story is finished for that year. So please be calm, never try for this. Next, one more thing where people lose marks in GATE exam is, as far as my knowledge is concerned, beginning of the exam they'll think like this: 80 marks ONGC, 75 marks some other PSU, maybe between 75 to 80 some IIT MTech. This is what they put in mind before going for the exam. Now this fellow will go and sit in the exam. Now see what happens. By the time the timer shows 2 hours 30 minutes, till then this fellow's exam is fine. He'll be getting some 65 marks to 70 marks decently till the first 2.5 hours. In the last half an hour, you know what he do? These points start coming in his mind, and then what he do? For whatever the questions he don't know the exact answers, he'll start trying putting some flukes. Actually means if ABCD is correct, he'll try to remember something which is not in his knowledge and try to put some answer for this. And in this last 30 minutes, this 65 to 70 score will drop to 55 to 60. So when going for preparation, definitely you should have these targets. But once you start sitting in your examination and once you have started solving the questions, these points should not come in your mind. Clear? Because if these points come in your mind, this is what it happens in last 30 minutes, and obviously this is what it happens. Clear to all of you? So because when looking at the question paper, it's quite common that even if you go for 80 marks, there could be chance that you directly know only 65 marks. Then please solve them and try to answer, but don't go for these kind of manipulations in last 30 minutes or 10 minutes or something. In December you can look, but not definitely in January. See, whatever you study, new topics or something until December, that's okay. But in January, please don't go for some other new topics that you never looked into before and all. Okay. But of course, still I recommend don't completely leave the topics, but from the topics you can spot some concepts where questions are coming frequently. You can revise those concepts. Okay. Am I clear? Please, if you're not confident with new topics at that time, please don't study the complete new subject. But in that particular subject, by looking at previous GATE papers, you can identify few topics where questions are frequently coming, so you can revise those new topics so that within less time you will be able to cover at least some important topics, and by chance if questions come from that particular topic again, you will be able to answer. No, it will take not more than 10-15 minutes, not even 10-15 minutes, maximum 7-8 minutes. Okay, by looking at the question, if your preparation is thorough, by looking at the question you will definitely get an idea what to do, whether to consider this question in which of these 3. What about aptitude? Aptitude is fine. Actually, English comes out for a few marks actually, which not more than I think 3-4 marks hardly, but the rest of the 11-10 marks you can answer it fine. GATE aptitude is really easy. Okay, and it's not as tough as CAT, but GATE aptitude is really easy. And in GATE examination, if your senses work better, means if your basics are very strong, you'll be able to definitely answer 60% of the paper for sure, undoubtedly. Okay, if your basics are very strong in any particular subject, you will be able to answer those questions. Okay, I hope that's clear, and time is also up. Any more questions? If you're liking the sessions that are being shared here, you can always like the videos, which you can give us something in return, and also you can subscribe to the channel, and also you can write some comments in the comment box of the video. Okay. It's not like you'll start aptitude at some time and you'll finish it shortly, but that's a general procedure that develops in you. Solving aptitude actually doesn't need any shortcuts or something, but still, if you want to go for one book, I could refer you. You can go for R.S. Agarwal, which is good enough to handle problems with gate. Okay, fine then. I hope that could be for here. For third years, actually you're not in third year. You are in final year. It's, you didn't study in the holidays. What can we do for that? If things have went as per the plan, then definitely you could have been in final year. But please don't waste time anyhow. If corona comes or something comes, whatever comes, you please keep on doing your things. Okay. Previously you can see when I'm teaching, someone is typing, some FBI something, I don't bother. You should give your 100%, let them do what they can do, and you do what you can do. Okay, fine, that's what I believe. Thank you all, have a nice sleep, good night.